that went something like, just making this up, of course, like that. Would you say you want to put a line through something like that? Yeah, I probably wouldn't be wanting to estimate that with a line. I'd be trying to do something maybe like this or something like, and that's just try all day long, and there's not going to be a good representation of the line because it's not linear. Okay, so maybe something that went more like a shape like this would fit better. And you would remember from, this is where the algebra kicks in, by the way, from your library of functions, chapter 2, section 6 or 7, I can't remember. And we looked at some of the different shapes that these graphs makes, and from that information, you would immediately say this looks more like a what? An x squared, right? Like maybe quadratic regression as opposed to linear regression. So these are the choices we're going to make. But right now, today's lesson is to basically focus on, can you get this data in the calculator, and can you get some scatter plots and get the regression and answer a couple basic questions? Because that's where our work's going to take off from there. So I want to be done with this question. Was there any questions that asked? Let's see. Part A says to draw a scatter diagram by hand. You will not be drawing anything by hand. You have a calculator, why would you draw it by hand? Not to mention in the practice out when people do this, and this happens every day, trust me, lots of data is being analyzed even as we speak. There are software programs that will draw scatter plots. The thing about drawing one by hand is probably obsolete at this point, but you could make an XY chart and graph these points. But you're going to use some kind of software to do that part. So that's why part B says, use a graphing utility to draw a scatter diagram. Graphing utility is a fancy way of saying calculator or software. C, describe what happens as the on-base percentage increases. If I had to sit here and BS all day about what happened, I would say, oh, well, as the on-base percentage increases, the number of runs scored increases in a linear fashion, or in a positive slope, if you will. Not going to ask you that either, because I'd have to read several paragraphs of your idea of what it means to go up as one goes to the right. I think you could just see that, okay? Solution here, okay, we got the solutions done. I came up with these questions because these are typical questions you will be asked. Given an x value, can you find the y? Given a y value, can you find the x? Okay, I can word that 100 different ways, so be careful. Basically comes down to two really basic questions. Did I give you an x value? Find the y. That's an easy one. That's the second calculated value. The little bit more difficult, not too much more, is when you're given a y, how do you find the x? You have to put the y into y2, run the line out and find the intersection, and read the x off the page. So we can do both of those, and that's what I want to be able to do. Okay, so let me pause right here. Say any questions about this whole procedure right now that I can clear up. Okay, I want to run through this again. On the next page, there are 4 problems. Take a note that the data is not as long this time. Okay, we're not out to kill you with data input. But I want to run through the procedure so we're pretty clear. Come test day, if you forget any part of this procedure, you're going to be in trouble, because if you're sitting there trying to get a scatter plot up, well, you still have a load of questions to answer about it. Well, it's going to be a long day. You see what I mean? So let's get the scatter plots up and running today, and that's the goal. All right, so procedure number 1, I usually back out of everything. I go to my y equals, clear out any work that I had. Leaving the plot 1 turned on, though, because I know I'm about to make another scatter plot. Also, if we go to the stat edit, you'll see that I have all that old information in there. I could, at this point, start hitting delete on all of this stuff, and that's going to take a while. Not to mention, you're liable to move up to line L2 up there and accidentally hit delete. You don't delete the entire list of values, you delete the entire list. It goes away. Then you have to go back to square one and set your calculator all back up again. So trust me on this one. Second quit and going to your stat editor and using the clear list option is usually the best method. It will save you from making some crucial errors during test time of deleting an entire list and sitting there without a calculator to finish the work. So clear list is a good way to go. I want to clear list second L1, comma done, I now have efficiently cleared out all the information that's in list 1 and in list 2. So when I go back to look at the stat editor, what will I see in list 1 and list 2? Two nice little lines is all I should see. Stat, edit, and there are my 2 lines. Do not worry about any of the other lists at this point in time as though we would use for some other type of regressions that we will not cover in this class. Okay. Now that we have a nice clean, clear list, 1 and list 2, what should we do next? Get the data in, right? I almost sometimes put the data in before I even read the problem. But you should probably be correct about this. And let's take a second to read the problem. The problem says, the height versus the head circumference. A pediatrician wanted to estimate a linear function that relates a child's height to their head circumference. Okay? She randomly selects 9 children from her practice, measures their height and head circumference, and obtains the data shown below in the list here. Let H represent the independent variable and C the dependent variable. We will not really worry too much about the names of the independent and dependent. Independent is always the X and dependent is the Y in the most general settings. Without changing the parameters, X is always the horizontal, Y is always the vertical. That's by convention. Therefore, by convention, the X is always the independent and Y is always the dependent. Not that we couldn't rename them, but that's the general convention. So now we can put the data in. So this is probably the most time-consuming thing, and you guys just do it at your own pace, but be careful to try and make sure you don't skip numbers or put wrong numbers in, because that will make a different answer. Even 1 decimal different will make a different answer. Scroll over to list 2 if you're there, or when you get there. When you get to the bottom of the list, you would like to see both of these lines line up so that you know that you did the same amount in both and that things are going as planned. You got the data in, Everybody there? I see some people still pushing buttons. Okay. All right, now that we have the data in, we go hit graph, right? See nothing. What should have we done here? Zoom 9 would be better, right? Because Zoom 9 will do actually a lot for us. Almost seems like we're getting away with murder here because it is going to the X values, finding the minimum and maximum and making the window that for you and doing the exact same thing with the Y values, all in the push of a button. Several things happen. Is we actually get the max and min on our window and it does it for us. So Zoom 9. Has everybody got this scatter plot? You've already got the line through it? It's okay, you got the scatter plot, that's fine. I don't mind jumping ahead. Now this is a point here where you have to determine what kind of regression you think, and we'll come up with some parameters as to what is better than not others. But just right now, from your point of view, does this thing look linear? And let's talk about the context of the problem. Children, as they grow, their head sizes generally do what? Grow right along with